Hello and welcome to Engineering with Rosie Live, and welcome also to our special guest for today's stream, Dr. Roland Schmehl. I didn't actually check with you about pronunciation of your last name, so I hope I got it sort of close.
Oh, that's absolutely perfect. Thanks and hello to everyone.
Great. So I'll get Roland to introduce himself properly in a second. But first, I want you to tell me in the comments, make sure that you can see and hear us okay, and tell me whether you saw the latest video that we did on Engineering with Rosie on Airborne Wind, and if you have any questions on that for Roland. So I'm going to start by thanking the sponsor of these live streams, which is WeatherGuard Lightning Tech. They make Strike Tape, which is a retrofittable lightning protection system for things that go fast, like wind turbine blades and aircraft. These live streams wouldn't happen without their support. So big thank you. And also big thanks to the Engineering with Rosie Patreon community who support the whole channel. So just to divert before we even get started, I guess lightning protection for airborne wind is a bit easier than for a conventional wind. You just put it down if there's a thunderstorm. Is that what you do?
Well, normally we don't have a connection that is electrically conducting necessarily. So there is a plastic cable going into the air. So that's one point. But of course, when there is rain, that can become conducting. So thunderstorm is definitely an area we need to look into what to do. But it's not the wind that's the problem, but the electricity then.
Okay. Oh, interesting. Okay. Well, yeah. So we uncovered something interesting in the first minute, so that's good. I learned something already. So, Roland, could you introduce yourself and a bit about your background and yeah, why you got into airborne wind energy?
Yeah, my name is Roland Schmehl, and I'm an associate professor here at Delft University of Technology. And I'm researching in airborne wind already since 13, 14 years now. And before I started on that topic, I was working at the European Space Agency on the Ariane 5 launcher, the upper stage engine. I looked at fuel preparation for aircraft engines and these kind of things. So my actual research background is computational fluid dynamics. And I really like difficult physical modeling problems. That's one of my expertise, I would say, and that's also what I like about airborne wind. It's a super challenging topic with many interesting things to discover. Yeah. So, and why did I start Kitebauer? So
Yeah.
I worked first for 5 years at the university teaching and doing research. And we had a group here, and that's where I was hired for, that was run by a former astronaut, the first Dutch astronaut in space, Wubbo Ockels. And he was investigating how to get power from the sky with kites. And he had this super interesting project. And after 5 years of working in that project, we decided, hey, let's spin this out and commercialize this. And that's the start of Kitebauer.
Okay, cool. And so, how much are you doing between the research and the commercial stuff? Because it's kind of interesting that I guess if you're a researcher, then you're researching airborne wind in general, and then yeah, your work with the company. Are you still involved day to day?
Yeah, I'm not day to day involved. I'm a co-founder of the company. So at the time we had, of course, uh, quite a number of interesting people and people who want to further the technology. So with that team, we spun out the company. I'm just one of the co-founders, but I do work 100% at the university, doing research on airborne wind, and in this way supporting also the technology development.
Hmm. Okay, cool. I just yeah brought up the video from Kite Power so people can see what it is that yeah what you've been involved in founding. All right,
Exactly. So
so
yeah.
yeah, so
I
keep going.
just wanted to, sorry, I just wanted to remark this was 2021 on Aruba, the Caribbean island, test
Mm.
installation.
everybody's testing in beautiful locations. I was talking to the CEO of Sky Sails, and their first system has been sold in Mauritius. So it seems like a good industry to get into if you want some nice business travel to some nice places.
Yeah, absolutely. I mean, you can see, and we will probably cover this later also, that the off-grid market is particularly interesting as a niche market to start this off, because within a few minutes you have the system up and running. You can easily deploy it anywhere on the planet. We even we looked at the deployment on Mars recently with my students
Oh,
for the
really?
future.
That's so funny. That's literally the topic of my next video that I'm working on right now is going to be wind energy on Mars, and one of the topics that I'm going to put in there is about whether airborne wind makes more or less sense than it does on Earth. So we'll have to talk about that. Actually, the more that I talk to you, the more I want to bring you in for future videos. Shipping was another one that we talked about on our previous call. So yeah, maybe you could be a guest again for some of those topics.
Yeah, sure.
Cool.
It'd be my pleasure. Yeah.
Thanks. Okay, so I just wanted to start with a little bit of a history, or like a recent history of airborne wind, and especially like the commercial aspects of it. And yeah, there's a few other topics that I know that you mentioned that you wish that I covered in more depth in the video, so we will get a chance to do them next. But yeah, let's start with a bit of some history of how the commercialization is going.
Yeah, commercialization, I would say we are still in an emerging phase. So you can see that except for Sky Sails, there is no one out and having test installations. So that step is still to be made. And you mentioned it also in the video, the robustness and reliability of the technology is still the bottleneck to overcome. So to get long-term operation of these systems without any components failing, that is what we still need to tackle. And I think we are on a good road. It just takes longer than we thought, as in many tech developments. But I mean, maybe rewinding a little bit. So the whole thing, Airborne Wind, started off in 1980 with a paper by Miles Lloyd, an American engineer at Lawrence Livermore. And he basically laid out the entire theory that we are still using today. And then only in about year 2000, it really picked up. We saw more and more companies and research groups getting involved. And since 2010, we have a constant growth, and we are now at around 60 research institutes and companies worldwide. So that's a big number. And I think we are on the good road to make this reality. And maybe one last point, all depends on funding. So this is really the crucial point here. We need public funding from the governments, but also private funding from angel investors.
Okay. And that's a topic we might talk about a bit more later, because that was also something that I talked about with the Sky Sales CEO. So speaking commercially, I guess the question that most people, well, my background is with conventional wind, so I guess I know a lot of people who are very into conventional wind and very sure that it's the only kind of wind energy that we ever need or will have. And if I had, one of them as another guest on this show, then what they would say to you is, well, Makani, they made a technology and it worked, and they had deep, deep, deep pockets behind them and it failed. So why was, yeah, well, they would use that as evidence for why it's never going to happen. Obviously you disagree, but can you tell me, like, what do you think was the reason for that failure? Do you think they chose the wrong technology, or do you think that the timing was wrong, or just tell me why you think it's going to be different for some of these other companies that are going now?
It's a good point, and of course it is a complex complex question. My opinion on the Makani case and also the very recent Ampix bankruptcy, so that was the second large company in the business, is they were growing too quickly, burning too much money, and going to a large scale system. So in a too short time. So what we were missing out is making these baby steps on small scale, learning, building up knowledge, iterating, and making the technology better and better. And of course, Makani had deep pockets, as you said, but they were also pushed to very quickly build a huge aircraft from scratch, the M600 that you see here flying. I think they just had about 6 years of making this, which is incredible in the aerospace sector. So this is the largest electric drone that was flying probably on the planet, and doing this within 6 years, going from a small scale demonstrator to that large scale is an amazing thing. But of course, the economics of the whole thing is a completely different story than technical feasibility.
That's something that I see a lot with emerging energy technologies, and especially in energy storage. You know, there's all of these new kinds of companies starting up. They're making stuff that sounds like it, you know, it's just a combination of all known technologies, all mature stuff, and there is a real temptation to just all of a sudden go really, really big really fast. Maybe floating offshore wind is another example where you see, you know, like really new kind of concepts, and instead of testing a small thing on the land first, they'll immediately go offshore with a, you know, like a 10 megawatt system. And yeah, so everything fails to start with. That's how you learn when they're developing a new technology. And so when you fail with something that cost you millions of dollars to build, that's a bigger hit than something smaller. But they're trying to get to market first. Obviously, they're trying to move fast and get that first mover advantage. So it's not an easy solution.
No, no, that's exactly the point. Of course, we are dealing with investors, and investors want to see the big market, the profitable market, captured as quickly as possible. And that puts up a lot of pressure on going big, making promises very early on. So that's a very unhealthy dynamics for high tech development. We see this all the time. But luckily, we have learned from this, and there is now the second league of companies that stay small or stayed small, and that can absorb the learnings from Makani and Ampix, and hopefully now do it in the second round, making it a success.
Yeah. Okay. And I did notice, so Ampix was also another rigid wing design, right? And
Exactly.
so I was wondering if, and then you compare that to, yeah, Kite Power Sky Sails, their soft wing design. So does it seem like that the, you know, the flexible wing are taking over the rigid wing now?
It does seem like that, but of course you have to see it from the background. The fixed wing solutions, they were considered more robust, more durable, more something for long term and large scale operation. But of course, the development needed a lot of finances. And that's what happened then. That was not viable on the long run. The softwing solutions, on the other hand, they are relatively cheap in development. A failure is typically not fatal because you can just relaunch the kite. They are soft and flexible. So that gives you a lot more options to do quicker development, have more lax safety standards because you don't have this massive aircraft circling around, which is potentially very dangerous. So all of these factors, if you count it in, right now the race is clearly led by the soft wing companies, but I would not say that's the end of it. There are also several fixed wing concepts out there on smaller scale that are definitely in the race.
Yeah, okay. I did hear from Twin Tech as well, and they've got a rigid wing, right? Let me just bring up their
Exactly. Yes,
the video
they are
I
one
can
of
show
the
that.
very early companies from Switzerland, and they really have an amazing, reliable energy drone you see flying here. And what's also interesting, all these concepts they use variants of different components. So here, this TwinTech drone has three propellers to launch and land vertically. And Makani, you saw, was different. That was a tail sitter drone where the rotors were in the axis of the aircraft. And you see all these variations of different concepts, which is also a reason why airborne wind is so interesting and fascinating, for me at least.
So those rotors are just for takeoff and landing. They don't generate the power. It's still a ground gen system.
This is still a ground gen system. You see a very small ram air turbine on the top of the fuselage. I mean, you saw it earlier, but this is only for providing the onboard power. So the three VTOL propellers are only for launching and landing. And that's the big difference to Makani. They use the propellers also for energy generation during flight, and as well Kitecraft. That's another startup. They follow in the footpath of Makani.
Okay, I'll bring that up in a second. So this Twin Tech, it's a 10 kilowatt prototype, and then yeah, fairly small wing, only 5.5 meters, and I guess that's the advantage of the rigid wing that it's more efficient, so it can be smaller. Is that right?
That is correct. I mean, the lift to drag ratio, that's the decisive property here that we know from Lloyd's theory from the 80s. So the higher the lift to drag ratio, the faster these kites fly. You have to imagine they are not, they don't have a propulsion system. It's the wind and the connection to the ground that makes them fly. And the lift to drag ratio has a very high impact there.
Yeah. Okay. I'll try and open that paper. But the next topic that I wanted to talk a bit about was crosswind flight, and because a lot of commenters in the YouTube video said, following in on from what you were saying about how some of these failures went really big, really fast. And another kind of similar thing is if you go too complex too fast, and a lot of people think that crosswind flight is too complex, it's not worth it. They really like that Altaros blimp design, where it was like a ducted shroud blimp. I'll try and bring up a video on that. Because it's just simple. It's just a normal wind turbine just sitting up there with a blimp, and you got no problem with taking off in low wind or anything. So yeah, can you tell us about crosswind flight and why? I mean, everybody's doing crosswind flight now, right? There's no companies not. Are there any major players who are not doing crosswind flight?
No, I wouldn't say so. And that has a reason. And that is actually what Lloyd described in his paper. When you fly crosswind, you can generate magnitudes of more power. So it's really a fundamental physical fact. Without crosswind flight, you you basically get a trickle electricity down the line. Your generator does not produce a lot, but with crosswind flight, you have a lot higher forces in the system that you can then convert into electricity. And that's what all these companies exploit. And you see that there are occasionally non-crosswind systems popping up, but they typically never make it to the to the market because of that reason. And Alta Aeros, for example, they also changed their market from electricity generation to mobile antenna platforms. So they still use the blimp concept. They still have generators on, so a small turbine on board, but that is for providing the power for this mobile antenna.
Okay. That's I didn't realize that they still had it powered up there. It still sounds complicated, but um, okay. So yeah, sorry, my internet is super slow here, so I couldn't download the Lloyd paper, but I've gone to the Wikipedia page instead on crosswind flight, and yeah, so I mean it's just this figure eight sort of pattern. And how much more power did you say? Like, what are the difference in wind speeds from crosswind flight?
So Lloyd, when you follow Lloyd's analysis, you come to at least an order of magnitude more power. I mean, he in this 1980s paper, he actually described that you take a commercial aircraft, so let's say
Mm,
a large airliner, you put it on a tether, and you can easily generate 5 to 6 megawatts of power. And that was at a time when wind turbines were still tiny. So
mm,
that was the vision that really
mm.
made an impact. But if you now bring in the physics, there are a lot of losses that were not considered in his theory that eventually reduce this power to only a small part. So,
Mm.
for example, the
So,
tether.
sorry, I just want to clarify. So, if you've got a kite flying in 10 meter per second wind, then if you fly in a crosswind pattern, then you're going to get 100. It's going to see 100 meters per second wind. Is that what you're saying? That sounds
Yes,
very large.
exactly what's essential is
Yeah.
the relative flow speed at the kite. That is what generates the
Mm.
forces, and the forces are proportional to the square of these velocities. That's a
Mm.
fundamental aerodynamic law, and you can see that
Mm.
with the relative speed, you can gain a lot. And wind turbines use the same concept as crosswind systems because a wind turbine is also a blade that's swept crosswind, only it produces
Yeah.
torque.
Yeah. Okay, that does make sense. Because I was thinking from a, an energy point of view, the power in the wind varies with the cube of the wind speed. So I was trying to think, where does this extra energy come from? And I guess you're sweeping out a much bigger area. So you're taking energy from, from this whole huge area that you're flying the crosswind pattern in. And it's the same with the wind turbine blade. It's another thing people don't understand very well. They think, why don't you put more blades and you get more wind? But actually, by the time that the next blade catches up to the where the one before was, there's only been just enough time for the air to move past, and so you're taking, in theory, a little bit of all of it. So yeah, I can see now how that is kind of similar. So yeah, cool. That's a good explanation, and I mean that's obviously massive. So yes, you would simplify things by not flying crosswind, but if you're, got, well, it's not even 100 times less power. It'd be more than that because yeah, the lift force. I guess it's proportional to the lift force, which varies with the square of the wind speed. So anyway, it's going to be huge. And in any case, it
Exactly.
doesn't seem like the crosswind flight is really the piece of the puzzle people are struggling with, right?
No, no, absolutely not. Um, the, the crosswind flight patterns, these were one of the reasons why airborne wind was picked up in about 2000, 2005. It was just a fascinating control problem. So many scientists and researchers tried to tackle that. And you see that most of the papers on airborne wind from that time are on the control. But that is solved. Now it's about reliability and robustness, avoiding failures of components that might lead to the crash of the kite. So that's the difference to the wind turbine. A wind turbine just stops operating while a kite can crash when there is something happening.
Okay. Yeah, sorry, I am having bad internet. Everybody else here's rolling fine, right? It's just me with my Australian quality internet. It's a huge joke about you'd think Australia is this like pretty developed country, but for some reason we just decided like 10 or 20 years ago that the internet wasn't really important for much, and everybody seems to have just dug in on that since then and refuses to put in any decent infrastructure. So this is frequent for me. So yeah, hopefully everybody else is probably largely Europe based, and I know the internet is fine in
I
Europe
hear, I hear,
and
I hear you
everywhere
perfectly.
else.
I
Okay,
hear you
my upload
perfectly.
speed is all right then. Okay, so I wanted to move on to some questions then. So I'm just looking through the comments from people online here. We've got a nice comment from Lawrence. Uh, I don't know, are you Danish? Is it Kirkbu? Or Kirkby, if not. Don't forget to like this video, everybody. Thank you, Lawrence. And yes, please do. That will help with the YouTube algorithm. Um, okay, so we've got a comment from Renbird. Deep but fickle pockets, big tech firms drop products a lot. And I assume that is written when we were talking about Makani. And I do think that is a problem in general with the energy transition. And maybe you can tell me what you think, Roland, since you're involved in the entrepreneurial side. It's not the same. You can't use the same kind of investment model for physical, manufacturing and technology, or like engineering, science based products as you can with like an app, right? You're not going to get the same kind of growth. You're probably not going to get any kind of special network effect like the social media platform, and it takes a long time as well. And then it's not always so easy.
I think Rosie is frozen, at least for me. Oh,
Oh,
we had you frozen for a
can you hear
second.
me now?
I hear you. Yes.
Did you hear my question, or should I say again?
I think I got this about funding, financing, and so on. It is funding in airborne wind is tricky. I would say there are two streams that we use. There is the public funding and the private funding. The public funding is actually quite good since about 2004, 2005. From the EU, we have a reasonably good and structural funding stream that allows us to systematically build up knowledge. But with that funding, you are not building prototypes on scale and have commercial teams operating. For this, we need private funding. And the situation there is good, but still, I would say challenging. Especially the last year was challenging in Europe, where a lot of high tech venture capital was reduced and many companies went bankrupt, not only in airborne wind, but also in many other fields. That was the situation here in Europe, but I think it has improved since then. At least with our own spin-off Kite Power, we are on a good track. We have now raised 2 million in 1 million in crowdfunding and 1 million extra. That will carry us through for the next few years.
Yeah, it's one thing that I like about one of the reasons why I think that airborne has a chance, when usually when I'm doing these kind of a little bit out there kind of wind energy, I'm just saying how I think they're stupid and they're never going to go anywhere. And I don't think that about airborne, partly because it has a possibility through to commercialization without it just being government funding and investors that don't care too much about getting a fast return on their money, because there are some markets, early markets, that you could actually make money from by serving markets that conventional wind can't. And when I spoke with Sky Sales, then they were saying that, yeah, their early market is 100% replacing diesel generators, which are very expensive. And as long as governments aren't actually subsidizing the diesel, which they commonly are, but if they're not, then Sky Sales is cheaper, he said. And I guess that other companies would be able to follow the same thing. And I guess that buys you a lot more time and to be able to make more products and try them out and improve it and grow in a market that conventional wind doesn't want to and fund it that way. Do you think that's important?
Yeah, I think this is very important, and that's why you see that Sky Sails is on Mauritius and Kite Power was on the Caribbean island of Aruba. These are exactly these niche markets. We also think about disaster relief, emergency crisis situations, because the big advantage of these systems is you can, as I mentioned at the beginning, you can easily ship them somewhere, deploy them, generate power, take them down, leave zero footprint, and go somewhere else. You can't do that with a wind turbine. It always needs a foundation.
Yeah.
And that brings me to another interesting point that relates actually to the interest in floating offshore airborne, because we don't have the tower and this huge bending moment on the floating platform. The floater can be a lot smaller because the force directly goes into that platform. So you need a swimming point and the mooring lines, and that's it. And so that's how we get to 90% mass reduction for floating offshore airborne.
Yeah, that was one of the big things that I got from my call with Sky Sales. I was aware of some of the possibilities for offshore, but then there's some others that I hadn't considered. So yeah, setting it up, it's going to be easier if you don't have to install the fixed bottom foundation. So any of the advantages between any kind of floating wind versus regular wind, but then the kinds of forces. It's just a towing force, and so you can use a anchoring system more like a ship rather than an oil or gas platform, or wind turbine is a particularly difficult case because it's like it's sticking up in the air quite high, so you got a big bending moment, and very very challenging. And then he also mentioned maintenance as well, because it's it's all just sitting there on the surface and floating, and you can tow it. You could tow it in to the port to do maintenance if you needed to. There was some quite some benefits that I got from that call. So that was really cool. All right, I'll move on to some other questions. So one that we've got from a commenter here, Royston Castellino, for commercial kite power, how can we launch and land the kite autonomously? And that was also topic of a lot of YouTube suggestions. A lot of people, like I mentioned, are very keen on the blimp idea, whether it's with helium or with hydrogen, though some other commenters pointed out that hydrogen's flammable, and Hindenburg and everything. And someone even suggested like a t-shirt cannon, that they have in sports events. They
Yes.
fire t-shirts into the stadium. Why not launch it with a t-shirt cannon? What are the different methods out there? And what do you think about the t-shirt cannon idea?
This is all not new to me, of course. We had thought about this for 15, 20 or 20 years now. So a lot of ideas are out there. And of course, you need to separate the useful and technically feasible ideas from the more nonsense kind of stuff. But for example, the blimp is something that my ex-boss, the Dutch astronaut, he already tried that. So they rented a blimp and they explored how to take that blimp and carry a kite to operational altitude and then launch it from the kite. That works wonderfully. The only thing is it's super expensive. And a blimp, to operate a blimp is also not so straightforward when it's windy. So these are all considerations to take. But to come back to the original question, the autonomous launching and landing, that's obviously one of the big challenges, especially for soft wing systems. That's also one of the points why Makani transitioned from soft wing to fixed wing in about 2009, 2010, because they just saw that the drone is much easier to launch and land and get into crosswind flight than a soft wing kite. But we see from what Sky Sails is doing that it's perfectly doable. They have this mast, the Ram air kite. They launch and land automatically, and I see that other companies are on the same path.
Yeah. So this was funny. In the first live stream that I did, I showed this part of this video, and so it shows it launching autonomously. But I mean, it only works if there's wind, right? If there's no wind, you can't launch in this way.
Absolutely.
Yeah.
Absolutely. The point is you need this minimum cut-in wind speed to take off and land.
Yeah.
And what's interesting now is you might be in a situation where you have higher wind speeds at altitude, but so you can produce power. But if you have to land, you cannot relaunch again. So it's actually a tricky optimization question. And but generally, with an airborne wind energy system, you want to avoid launching and landing as much as possible. Stay flying as long as you can, because all these launch and land maneuvers, they also take time and they will eat away from your capacity factor.
Yes. Yes. Okay. There's an interesting comment here from Christophe. So, Beaupoil, I guess, shipping in French, sorry. Makani launched one of the early and small prototypes with air pressure cannons. Is this true? Can you confirm?
I can confirm they had a pneumatic catapult to vertically shoot a fixed wing system into the air. So that's a
Right.
nice that's a nice thing about Makani. Maybe for people who want to look that up, when Google shut down the business, I think it was in 2020, they opened up all the data of Makani and made it available to the public. They also gave away all the patents. So there is a non-assertion pledge on the patents. So anyone who wants to pick up from where they stopped can make maximum use of all that knowledge. And you will find
Yeah,
this
that's
on
cool.
archive.org. So the Internet Archive has all the Makani stuff readily available.
Okay. Yeah, I used it for the. There's some good resources for the video as well. I should have used those videos instead of that. This is the one I was showing then. Is from the feature film Pulling Power from the Sky, the story of Makani, which is definitely an interesting watch. So yeah, I just wanted to mention when I talked with Sky Sales, they said that it was the launching and landing that is the hardest part to automate. And at the moment, they have got a couple of people, operators, go with every kite. Then they only have one now, so that's not so bad. But if you obviously it's going to be a bit of a I don't know, it's a bottleneck to their expansion. At the moment, he said it's not really two operators; it's like 1.5. It's an operator and an assistant who doesn't need to be there all the time. And I think it was in the next few years they want to move down to one and then zero. And it was they said that the crosswind operation is no problem nearly all of the time, even with gusts, that they can take care of that. But what's really difficult is when there's gusts during takeoff and landing.
Yep.
Not to mention, obviously, that you need some wind. Is that align with your experience?
Absolutely, because when you launch and land, you're obviously close to the ground. When you're close to the ground on a short tether, a wind gust and a quick dynamic movement of the kite can easily lead to a crash or that the kite gets into a orientation that you cannot control it anymore. So that's the critical phase. And coincidentally, we are exploring that phase now in a new EU project that we are just launching, Meridional. It's about the physics of wind and the interaction with the wind turbine and kites, and launching and landing. And the stability of this regime is one of the core areas there.
Okay. That will be interesting to follow. And then I wanted to also raise, somebody else got in touch with me, someone from Enerkite. I've just pulled up, I think this is quite old, so this isn't what he's talking about, but he got in touch to let me know that they did. Oh no, it was in 2012. They had a 72-hour continuous flight in 2012, and then fully automated operation of its system in 2021, including fully automated launching, transition into harvesting cycle, harvesting and landing without any interference by a human pilot, repeatedly over 2022 in different weather conditions, including no wind at all on the ground, up to 5 to 7 meters, with gusts handled by the system. So he wanted me to ask you about that. It sounds they're very, very big claims, and it's hard to see why that wouldn't be the leader and the one with the commercial sales if that was the case. So what can you say about the way that Enerkite are doing it in their progress?
And Enerkite is one of the pioneers, I would say one of the 4 or 5 companies that really started commercially on airborne wind. And so they have a huge buildup of knowledge. And they have a very particular concept. It uses a rotational mast to actually swirl the kite into the air. And you saw this in the video. And I would say I know about these claims, and they might be perfectly true. The point is, and that's the big challenge in wind, you need to be able to do that in all conditions at all times. So it's not enough to have 1 or 2 very successful launches and landings. We also had that with our kite, obviously, but it's about repeatedly do it right. And I think this is where we are still where we still have some homework to do. And it is not something that you can do overnight or in a year or 2. This is experience-based development, a lot of trial and error and learning. And that's also the path that wind turbines went through. I mean, they took 20 or 30 years to go from where they were in the 80s to where they are now. And that's not something you can accelerate indefinitely and squeeze it into 10 years.
Yeah, that's one thing that I think is people often will compare any technology to either wind or solar, the cost reduction or the rollout in global capacity. And I think that the difference now is that when wind and solar were developing, we didn't have any good renewable energy, and now we do. So the need is a lot less, I think. So, solar definitely had some help from government programs and subsidies and that sort of thing, like a lot. It really did make a large amount of the initial volume. And then, China supported it quite strongly to, really refine the manufacturing and get them so cheap like they are today. But I wouldn't imagine that a government is going to support airborne wind in the same way, because we have wind and solar already that we can just put more and more and more out of. So I think that's a big difference. And I don't see it with airborne. Like I said, I see that there is that initial niche market, and then in the end there is some advantages compared to conventional wind that could turn out to be big in terms of less materials use, and maybe advantages offshore. But I definitely, when people say, wave energy or tidal, it's got to happen. Just look at, solar panels were expensive 40 years ago as well. I don't really see the analogy. What do you think about that? Do you expect government support in the same way that solar or wind saw in the early days?
This is exactly what we are trying to build up now. So I think over the last... Do you still hear me? Yes. Over the last 2 years, basically we have set up our industry association, Airborne Wind Europe, which mostly focuses on Europe, but we have also pulled in the US and other countries. And with the formation of this industry association, we have also a bit I call it a lobby instrument to centralize the information and PR activities on airborne wind, and that made a big difference, I should say, to address governments, policymakers, and so on. And I do see a change there. So, but of course, if we wouldn't have wind, there would be a much stronger push. So conventional turbines, but we do have them. We also don't see airborne wind as a competitor to wind. Maybe that's important to say here. It's a complementary technology. It uses a different resource. Wind at higher altitude has a different characteristic than the ground, the wind close to the ground. And so you have different generation patterns. And within these fluctuating resources, this is very important to have a balanced energy output. So that's why the interest now to these hybrid power systems where you combine wind turbines with solar panels, and we hope also with airborne wind and other sources, plus a battery, you can provide smooth power. And even
Do you,
diesel has a role in there, I should say, because you use a diesel gen, a small one, to capture the peak loads that you might have in the system and to reduce on the battery capacity that you need. Sorry.
yeah. No, that's good. I'm just aware we're using up most of the time, so let's keep moving through the questions. Here's one from Jim Arada. Where do you see the sweet spot of scale with the parasail kite, and how does that compare to a rigid kite like tetrahedral?
The sweet spot, I would say I shouldn't make any big statements on that because we simply don't know. The soft wings are right now on a scale between 25 and 100 square meter size. That's although this is still small, when you stand in front of such a kite, it is huge. It's a lot bigger than a surf kite. Um, I would say the next step from these 100 kilowatt systems is to 500 kilowatt, and that I have not seen yet for soft wings. I should say maybe the one exemption is SkySails. Before they went bankrupt in 2016, they had a 320 square meter parasail to pull ships, and that produced several tons of pulling force. So this would already go into the direction of 500 kilowatt. But megawatt is still a bit on the vision side of our thinking. So that's the next step. Of course,
Okay.
in simulations we do all that, but prototypes are not on that scale yet.
Yeah, of course. Okay, so here's another couple of questions which might be related. So, hold on, where did we? Oh, yeah, here. Yeah, from Royston Castellino again. How can we power the kite control unit if we fly continuously? And then Clive Flint asks, can you put solar cells on the kites? Would it be worth doing? So that would be my initial thought for how you would would power the control unit for a ground gen
Yep.
system. Is that what you do?
No, we don't do that. What we do is,
Ah,
you saw this with Twin Tech. They had a small
yeah.
ram air wind turbine
Yeah.
in the plane.
Yeah.
We have a small, not so small ram air turbine on the kite control unit. It actually looks like a powered paraglider where the pilot has a propeller and a motor on his or her back. So we use that same concept. Indeed, here you see it where your mouse pointer is, or it's the turbine on the
Yeah.
top. Exactly. So that's a lot better than solar panels because we fly fast. Anyway, that means a small propeller turbine gives you quite a lot of power already because the wind speed is very high. To get that power from solar panels, you need a huge surface. And on a fixed wing system, you don't have that surface because it's small. On a soft wing system, you have a flexible membrane, which is quite difficult to have
Yeah, true.
solar panels. So not a good idea.
Yeah. Okay. All right. I'll just try and go to some of the other YouTube comments. I won't pull them up because there's a lot and it's hard to find them, but just some of the categories. So one of the interesting ones was, and I'm interested in it too, the possibility of arranging them in arrays or wind farms. So I think I mentioned it in the video that that would be if you like really carefully choreographed everything, you might be able to smooth out this pumping cycle. Then of course just the same benefits that you get from any kind of wind farm versus one single wind generator. How do you see that going forward, and how do you, one of the comments or that was raised a few times, how do you stop the kite strings tangling? I think someone compared it to when you put your headphones in your pocket, and it takes no time at all for the cable to tangle up. How do you deal with those kind of issues?
Yeah, so for now, we have only rarely operated the systems together. We did that for test installations, but then what you do is very easy. You just go far apart. So you
Mm,
know how long your tether is on the drum, how long you can reel out. So you double that distance, and that is where you place your systems. So the tether can never entangle.
mm,
And this is for a wind turbine. You also need to stay apart 10 times the tower height, right? That's because of the shadowing effect, aerodynamic interaction. You say 10 times tower length. That's the
mm,
spacing of a wind turbine. If you now take a wind turbine with 100 meter, you easily end up at 1 kilometer distance between wind turbines. This is far longer than our tethers are. So
mm,
with airborne wind, you get to a similar spacing actually than for a conventional wind park, even if you stay conservative and don't allow any overlaps. Of course, the
mm,
idea for the future is to synchronize the operation in such a way that you avoid tethers entangling. So you can have some overlap of the operational footprint, but of course that will trade off with operational safety. But we are not there yet to explore that
mm.
in
Okay.
real in real.
Yeah, obviously, I mean, there's the only not even been that many tests of single units, let alone putting the resources into making a whole array. But then how does the land area end up? And this was kind of a surprise myself at asking this question because I'm constantly annoyed at people that want to compare the land usage for wind compared to the land usage for I don't know coal or something because obviously it uses the land but it doesn't prevent you from using it for other things. Maybe airborne would, which is kind of related to another question we might get to on regulation because I can't imagine a lot of activity underneath the wind farm of kites flying around if there was a failure and they fell.
Yes.
But how does the land area end up
Yeah,
compared
especially
to
now.
normal wind?
Yeah, clear.
Mm,
Especially now, while we are still developing and testing, of
mm,
course, you don't allow anybody below the kite. That's clear.
mm,
But the idea is for the future to reduce this footprint that we need. And one thing that you can easily imagine is an intelligent system will be able to pull in the kite quickly with the winch to avoid that it crashes far away from the ground station. So these are safety mechanisms that we are already, um, let's say, exploring in simulations, but have also implemented these into the system. Sky Sails has that, Kite Power has that, for example. So these are rapid retraction systems that avoid that the kite can crash somewhere far away. And
mm,
again, there is a difference between soft kites and fixed wings. You can imagine they have different impact classes, if you
mm.
say it this way, and that requires different safety mechanisms.
Actually, that reminds me of one comment that I got somebody who had been a kite surfer, I think, for, or yeah, I think it was kitesurfer for a while, and he said, "Yeah, you would think that it would be kinder to birds, but I know one time I I knocked a seagull out, took a seagull out with with my kite, not on purpose. He wanted to clarify, just happened to cross paths. So I guess they can still hit hard, maybe presumably not as hard as a as a rigid one though.
Exactly. The speeds at a wind turbine are a lot higher than the soft kites, for example.
You
And
mean if it's when it's falling? Yeah.
and when it's sweeping through the air. So a wind
Oh.
turbine, the rotor tip, you have to
Mm.
imagine modern wind turbines, they go to almost to transonic regime. So that means the wind speed at the tip is at Mach number 1.
Really?
Yes.
I'm not sure that aligns with what
It, it,
understand about it.
no,
But
not what you install now, but here at the
yeah.
university we
Oh, okay.
investigate
Yeah.
transonic regimes at winds at the tips and of the blades, and
Yeah.
that is a
Sounds
very high speed,
sounds
and that
noisy.
it is noisy.
People are worried about noise from regular wind turbines.
Exactly.
Imagine having sonic booms. Is that what happens? This is a very interesting topic for
Well,
another day. I'm very
exactly. Speed
yeah.
is
Wow.
noise. There
Yeah.
is a direct correlation. But my point was with a soft guide, you fly at 20 or 30 meter per second, and
Yeah.
that's completely in the subsonic regime. And these flight speeds, they have a different effect than on birds if they hit the
Mm.
soft kite or the tether. That's my point. But a
Yeah.
turbine blade is different because it also sweeps close to the ground.
Mm.
And I know from offshore, this is exactly the dangerous area where the birds fly close to the sea surface, and then you have the blades going through there at very high speeds.
Mm. Yeah, okay. I want to do a video on wind turbines and birds in the future. I've been intending to do it nearly as long as I've had the channel because I'm a big bird nerd. We have a lot of great birds in Australia, and it upsets me that people think that I don't care about birds because I am into wind energy, and it's really not nearly as big a deal as it's made out to be. But we won't go into that now because we're definitely or we've been going at it for about an hour, so we should try and wrap up. But I'll just try and get to a couple of questions quickly. There's one that we can answer quickly, I think, from King Dimitri Clips. If you fly higher where the wind is stronger, will more energy be produced? And maybe you can answer
Yeah,
that in one
absolutely.
word.
Exactly. Well, 3 words. You showed it nicely in one of these animations. We have wind shear. So the higher you go, the higher the wind speed. And that's not a general thing, but in statistically, in average, that's the case.
Mm. And related question from me, way higher. You get the jet stream with much faster wind speeds, but you don't see anybody trying to get up that high. Can you quickly explain why not?
So indeed, the jet stream was a bit the target of these very early pioneers that I mentioned, because you have 100 km per second wind speeds there, or even higher. So that sounded just super attractive to harvest that
Mm.
energy. But there are 2 problems. Problem one is you need a very long tether. Very long tethers produce a lot of aerodynamic drag. So in the
Mm.
end, you will kill all your efficiency and you will not see any power arriving at the ground. There are ways
Mm.
around that with the so-called dancing kite system, but that goes more into another direction. But the other point is the jet streams are not localized. They meander and wander around.
Oh.
So you actually, that's also what I learned, you would need to track them with your system from the ground, which is, of course, an impossible task. So
Mm.
for these 2 reasons, nobody thinks about this anymore seriously at the moment.
Mm. Okay. Just do one more question. There's heaps of good ones, and I mean I did a live stream on Airborne about a year ago. Maybe we'll do another one in another year and talk more about the progress and stuff. But so yeah, this one from Social Downclimber, very interested in ship mounted units. Would there be any interest in this from navies for saving fuel costs as well as shipping? And you did already mention Sky Sails. That's how they started out, and they got up to, what was it, already 1 megawatt system. It's obviously simpler to put on a ship. You don't have to worry. I guess you don't have to worry about reeling in and out, and you don't need a generator, so you'll get some extra efficiencies and save some costs. Sounds much more appealing than generating electricity. But why didn't it take off?
Yeah, so also here a bit of speculation, but what we know from Sky Sails is that the shipping market, at least at the time, 2015, was a very competitive one. Nobody wanted, although there was pain in saving fuel, nobody wanted to spend the extra million to purchase such a system and mount it on the ship. So that's why it kind of grounded. But we see the ship, I call it kite-assisted ship propulsion. We see this market now getting interesting again. There is Airseas, that's an Airbus spin-off in southern France. That is all in the media right now because they installed a test system on a big cargo ship. And there is Beyond the Sea, another French initiative by Yves Parlier. So the French seem to be very active in this kite-assisted ship propulsion market.
Yeah, right. And yeah, we'll be doing an episode on shipping at some point, and I will definitely be getting in touch with you, Roland, for some info before I do that, because it sounds like a topic that, all of the interesting things that are going on there. Yeah. Okay. Well, we're going to have to wrap up because I have to go and I've taken up enough of Roland's time. So yeah, thanks heaps for joining us today. It was really good to be able to, and just ask any random question that came to me and the viewers. So thanks for taking the time to be with us today.
Was a pleasure. Thanks for the invitation and the opportunity. And let's continue this on some other topics. Indeed.
Yes. Yeah. No, it's been really good. And let me know, viewers, how you like this. I've kind of started this new format the last couple of videos where I, make a proper video, a pre-recorded one. I put a lot of effort into, release that, and then give an opportunity to ask questions and stuff, and follow up with a live stream a week later. Do you like that opportunity to ask some tricky questions of an actual expert? Because yeah, I know early on in the YouTube channel, it was me talking about stuff that I was an expert in, and now I just do whatever I think is interesting, and what, viewers tell me is interesting. So I'm not usually as much of an expert as even a lot of the viewers. So tell me if you think that this is a good format and want to see more of it, and I will keep making sure to get great guests like Roland to come on and answer the hard questions that I can't. Okay, so I want to mention that coming up in March 11th and 12th, I'm going to be hosting some sessions at Fully Charged Live, which is in Sydney. So anybody that's in Australia, then come along. And I have a discount code in the description where you can get, I think it's 10% off tickets for that, and I will see you there. So thanks again to WeatherGuard Lightning Tech for sponsoring this live stream. WeatherGuard also have a great tech newsletter and a podcast, which I co-host with Alan Hall and Joel Saxum each week. The links are in the description. And in that, we talk about all kinds of clean energy tech news. The latest podcast episode was a bonus episode, actually, on recyclable wind turbine blades. We got into a long discussion on that. Couldn't fit in the regular podcast. So, yeah, check that out. It's about, are they worth the effort? And I kind of controversially think that it's not the biggest problem that we should all be focusing on, and I have no problem with them just sitting in landfill and not releasing any carbon into the atmosphere. So yeah, check that out in your favorite podcast app, or you can watch it here on YouTube, where the link's in the description. The next live stream is probably going to be with my favorite and probably everybody's favorite YouTube climate scientist, Climate Adam. They're going to be talking about what we think are the worst climate change solutions ever. So that should be a fun, light-hearted one. And yeah, feel free to put suggestions for what you think that is, what you think has been the worst climate change solution ever. Yes, and then like I said before, the next proper video that I release is probably going to be on wind energy on Mars. I get asked about this surprisingly often, and so it was really interesting, Roland, to hear you say that that's a question that you're working on too. Once again, yeah, leave ideas for what you would like to see covered in that video in the comments if you have any. Yeah, and just always need to thank as many times as possible the Engineering with Rosie Patreon team for their support. If you want to join the team, and we have a private Discord server, talk about all kinds of, energy nerd stuff, then yeah, I'll try and show the link here. Did that work? No. Yes. Oh, it's not working. Anyway, the link's in the description, showing up there very, very badly. Another last big thanks to Roland for joining us, and then huge big thanks for everybody that joined us today and left comments. We haven't got to them all, but yeah, hopefully we answered a lot, and I'll keep the rest in mind for the next time that I do a video on airborne wind. So thanks so much. I'll see you in the next video.
Thank you. Bye-bye.